But what about relative velocities? A couple of things we might think of here. For one, I might see two buddies charging at each other at 0.6 c. Then they're certainly getting closer at a rate of 1.2 c, so certainly they ought to see each other approaching at 1.2 times the speed of light, no? Or, it's actually the same problem. Suppose I see one of my buddies heading out at 0.6 c, and then he throws a fastball at 0.6 c relative to him. Shouldn't that fastball be traveling faster than the speed of light from my perspective? Surprisingly, it turns out the answer is no. Let's look at these equations here. I've got delta x and delta t in terms of delta x primed and delta t primed. If I simply divide the two equations, well then on the left-hand side I have delta x over delta t. That's the velocity in the rest frame. On the right-hand side, these gamma factors will cancel out. And it does get a little complicated. But what I want to do is I'm going to divide, well, let me write it down. This isn't quite the velocity because it's still delta x over delta t instead of being the limit as delta t goes to 0, but everything holds up in the limit. I'm going to use u as the velocity because I already have a v for v relative. So u is going to be delta x primed plus v relative delta t primed all over delta t primed plus v relative delta x primed over c squared. Now what I want to do is I want to divide each of these terms by delta t primed. As long as I divide everything on the top and bottom by it, I'm fine. I've treated everything the same, and what I end up getting is this relationship right here. Our new velocity is the old velocity, delta x primed over delta t primed. The delta t's cancel here, so it's plus the relative velocity. That's what we expect from Galilean transformation. But on the bottom now, I've got this 1 plus the old velocity, u primed, times the relative velocity over c squared. And this term here keeps us from ever getting an answer larger than the speed of light. So let's take the example right here. When he throws the baseball at 0.6 c relative to himself, moving across, well, that means u primed is 0.6 and v relative is also 0.6 c. So what I find is that u is equal to 0.6 c plus 0.6 c, all divided by 1 plus 0.6 c, this is squared, or c is squared, over c squared. That ends up giving me 1.2 c divided by 1.36. Notice that's bigger than the 1.2. As a result, the total velocity will be less than c. Bringing that up here, 1.2 divided by 1.36, it's only about 0.88 times the speed of light. Fast to be certain. but not faster than the speed of light. And basically that's just a result of the fact that our sense of time shifts as well as our sense of position.